holding a tablet that was written thousands of years ago and being able to read what it says. It's an amazing thing.
Plimpton 322 is often called the most fascinating and perhaps the most sophisticated mathematical artifact to survive from the ancient world. For days, the AI's processors hummed, tirelessly scanning for patterns invisible to the human eye. Its subject, a 3,700-year-old Babylonian tablet known as Plimpton 322. When it was first discovered, no one could grasp its significance. For decades, it was dismissed as nothing more than a teacher's exercise sheet.
At the time, we didn't realize how important it was. Subsequently, it has become one of the most studied objects from the ancient world.
But when the AI completed its analysis, the truth emerged. What it revealed wasn't a text of kings or myths, but pure mathematics, a flawless system of geometry, existing more than 1,500 years before its time. A discovery so precise, it didn't just rewrite history books, it suggested the presence of an ancient intelligence that challenges everything we thought we knew. For over a century, this clay tablet rested quietly in the climate-controlled archives of Columbia University. A fragment of baked clay, no more than 5 inches wide and 3.5 inches tall. Its story began in the early 1900s, buried beneath the sun-scorched earth of modern-day Iraq, near the ruins of the Sumerian city of Larsa. It was unearthed by Edgar Banks, archaeologist, diplomat, treasure hunter, the man later said to inspire the character of Indiana Jones. Like everyone else at the time, Banks had no idea what he had uncovered. The tablet bore an intricate script known as cuneiform, one of humanity's first written languages, pressed into wet clay with a reed stylus. But unlike most tablets, this wasn't a story, a prayer, or a royal decree. It was numbers, 4 columns, 15 rows, nothing more. Yet infinitely more than anyone imagined. For decades, the sharpest minds in archaeology and history studied Plimpton 322 and reached what seemed like a simple conclusion. They assumed it was nothing more than a teacher's tool, a worksheet filled with math problems for students. Others thought it might be a scribe's ledger, used to tally trade goods. It fit the narrative. The Babylonians, after all, were masters of commerce and bureaucracy, and the numbers made sense, at least on the surface. They were written in the Babylonian sexagesimal system, a base 60 system. It's the very reason we still count 60 seconds in a minute and 60 minutes in an hour. For its time, this was an astonishingly advanced form of mathematics. Yet still, the tablet was brushed off as a historical oddity. But there was a problem. The numbers didn't look random. They followed a pattern, strange, precise, and oddly beautiful. Most ignored it. But for a handful of mathematicians, it was a thorn in the side of the accepted story. This wasn't about hidden codes or conspiracy theories. It was about a growing suspicion that the official explanation didn't add up. The numbers seemed to describe the sides of right-angled triangles, what we now recognize as the Pythagorean theorem. Only here's the twist. This tablet predates Pythagoras by more than 1,000 years. How could the Babylonians have known this? And why create such a meticulous list of Pythagorean triples, some involving numbers so massive they describe triangles almost impossible to stumble upon by chance? One line alone points to a triangle with sides of 12,079 and 13,500, calculations of staggering accuracy. It defied logic. And so, for over a century, the tablet remained an enigma, a ghost in clay, a whisper of lost knowledge that refused to let go of history's edge. It was a message frozen in clay, locked away for nearly 4 millennia, waiting for a key humanity didn't yet possess. But that was about to change, in an age defined by data, algorithms, and computational power. A new kind of mind was unleashed on this ancient riddle, artificial intelligence. The silence was about to shatter, and the revelation would be nothing short of terrifying. For generations, scholars had tried and failed. They studied Plimpton 322 through the lens of modern mathematics, searching for answers they already thought they knew. But the breakthrough came when researchers decided to abandon human bias and let a machine search for patterns on its own. They fed a high-resolution scan of the tablet into a specialized AI, software designed to detect relationships hidden deep within massive datasets. Unlike human researchers, the AI had no preconceptions, no theories about history, no cultural baggage. It was a purely logical mind, free to examine every wedge, every etched line, every minuscule imperfection in the clay. And then it happened. The AI uncovered a truth that detonated like a bombshell in the halls of academia. Yes, the numbers related to triangles, but this wasn't just a random list of examples. This was something far greater. It was a trigonometric table. Now, I know the word trigonometry might bring back memories of high school math class, but don't tune out just yet. Because what the AI revealed wasn't ordinary. It wasn't Greek. It wasn't based on circles and angles, like the system credited to the Greeks centuries later. This was something entirely different, something that shouldn't have existed in 1800 BC. Greek-style trigonometry is powerful, but it's messy. It relies on approximations, numbers that stretch on forever, like pi. Useful, yes, but never perfect. What the AI uncovered was something entirely different. The Babylonians weren't working with angles at all. Instead, they built their trigonometry on exact ratios, and with their base 60 number system, they achieved something no one else in history ever has. The world's only completely accurate trigonometric table. No estimates, no rounding errors, just pure mathematical precision. Picture yourself as an ancient builder, standing at the foot of a colossal ziggurat, a stepped pyramid stretching toward the heavens. To construct it, every slope, every tier, must align with flawless consistency. With Greek-style math, tiny errors would accumulate, threatening the structure's stability. But with the system recorded on Plimpton 322, you could design perfect slopes and perfect angles, every single time. The AI revealed that the 15 rows carved into the tablet weren't random scratches. They were a carefully ordered sequence of right-angled triangles, their slopes decreasing in a precise and logical progression. This wasn't a student's homework. This was a master blueprint, a tool of staggering genius, centuries ahead of its time. The machine didn't just translate the numbers, it resurrected a lost science. It showed that over 1,500 years before the Greeks, the Babylonians had already mastered a form of mathematics more exact, and in some ways more advanced, than the one we rely on today. And that revelation cracked open a terrifying truth. The message of Plimpton 322 is chilling, not because it predicts doom, but because it exposes a lie we've been telling ourselves about history. We like to imagine human knowledge as a neat ladder. Babylonians, Egyptians, Greeks, Romans, and finally us, each step building cleanly on the last. But this tablet suggests something far stranger. Nearly 4,000 years ago, humanity may have reached a dazzling peak of understanding, only to plunge into darkness for millennia. The Greeks didn't invent this knowledge. They rediscovered fragments of it, broken and incomplete. The scale of that loss is almost incomprehensible. It's like stumbling across starship blueprints hidden inside a medieval castle. It doesn't fit. It shouldn't exist. And yet, it does. So let's pause and think about this for a moment. If the Babylonians really had access to a perfect form of mathematics, what could they have done with it? This wasn't just about stacking bricks into pyramids. Trigonometry is the very language of the universe. It's how we measure the distance between stars, design complex machines, and chart entire landscapes. Could the Babylonians have mapped the Earth with unimaginable precision? Could they have predicted astronomical events with an accuracy that rivaled modern supercomputers? Take the legendary Hanging Gardens of Babylon, one of the 7 wonders of the ancient world. We picture them as lush terraces rising above the desert. But what if they were more than that? What if they were a triumph of geometry and engineering, constructed using this lost mathematical perfection? This tablet forces us to ask, what else did they know? Plimpton 322 may be just one page from a vast body of work, a single surviving fragment of a library of genius. And here lies the terrifying truth. Knowledge can be lost. Civilizations can move backward. Entire scientific systems can vanish, swallowed by war, disaster, or simply the erosion of time. What if more tablets still lie buried beneath the sands of Iraq, holding secrets that could rewrite physics, astronomy, or engineering as we know it? What if Plimpton 322 is merely the tip of a colossal iceberg? We've long dismissed the Babylonians as primitive, but the message etched in this clay suggests the opposite. In some ways, they may have been more advanced than us. They weren't just setting out on the journey of discovery, they might have already arrived at a destination we have yet to reach. And that raises the biggest mystery of all. Where did it all go? How does a civilization with this level of brilliance simply vanish? This is the question that still keeps historians and scientists awake at night. The official story, the one told in most textbooks, is depressingly simple. The Babylonian Empire was plagued by conflict. It rose and collapsed repeatedly, conquered by the Hittites, the Assyrians, and eventually the Persians. In the chaos, libraries burned and entire cities were reduced to ash. In times of chaos, knowledge was a fragile treasure. It wasn't stored in public schools or libraries. It was guarded by a narrow class of elite scribes and priests. If that class disappeared, so too did their secrets. It's entirely possible that the flawless trigonometry of Plimpton 322 was once such a guarded secret, a tool reserved for a chosen few. And when they were gone, the knowledge vanished with them. That's the tidy textbook explanation. But is it really that simple? Can a society suddenly wake up one day with a form of mathematics more advanced than anything the Greeks would develop over 1,000 years later, and then just lose it overnight? Or are we missing a crucial piece of the puzzle? This is where the story drifts into the unknown, because Plimpton 322 doesn't just rewrite history, it hints at something far stranger. What if the Babylonians weren't the inventors of this knowledge at all? What if they were merely the inheritors? Think about it. This theory points to the possibility of a far older, globally advanced civilization, an ancient golden age that collapsed long before Babylon was ever built. Survivors of that forgotten world may have scattered across the globe, carrying with them only fragments of their brilliance. Perhaps Plimpton 322 is one of those fragments, one page of a lost scientific textbook, carefully copied by Babylonian scribes who may not have even fully grasped its significance. This could also explain why echoes of advanced knowledge appear in other corners of the ancient world. Mysterious, out-of-place technologies and architectural feats that seem impossible for their time. It reframes the Babylonians not as pioneers of genius, but as archivists, librarians of a world almost erased from memory. But there's another layer, one that's even more unsettling. Because if you read the ancient Babylonian texts, and even earlier Sumerian writings, you find something extraordinary. Again and again, they describe powerful beings descending from the heavens, bringing with them wisdom and knowledge that changed the course of human history. They called them the Anunnaki, celestial beings credited with giving humanity the gifts of law, agriculture, and science itself. So, is it really so unthinkable to wonder if this flawless mathematics wasn't a human invention at all? Could it have been an extraterrestrial language, a divine blueprint for understanding the universe, handed down to a chosen few? Maybe Plimpton 322 isn't a textbook written by human hands, but a user manual left behind by visitors from another world. And then comes the most unsettling theory of all. What if this knowledge was never lost, but deliberately hidden? Imagine a secret order of scribes who understood the power of this perfect math. They knew it was a key to raising monumental structures, predicting the movements of the heavens, perhaps even unlocking technologies capable of unimaginable destruction, surrounded by war and human greed. Maybe they decided we simply weren't ready, so they hid it, not by burying it underground, but by leaving it in plain sight. A clay tablet disguised as a dull accounting ledger, destined to be overlooked for thousands of years, waiting silently for a future mind, perhaps not even a human one, but an artificial one, capable of finally unlocking its message. Which leaves us with haunting questions. Has humanity already lived through a technological reset? Are we only now rediscovering secrets our ancestors once wielded with mastery? What do you think? Drop your thoughts in the comments below. And if you want more journeys into the mysteries of our past and future, don't forget to like this video and subscribe. Because sometimes, the truth isn't just stranger than fiction, it's buried in clay, waiting for us to see it.